All right. So what you had to do was follow the format for your hyperbola. It's very similar to your ellipse, except for a couple of changes. The foci will fall outside of the ellipse part of where the ellipse would fall inside. The foci on the hyperbola fall outside, like into your two little parabolas here. It's a minus. The rest should pretty much work the same, and your asymptotes. Your asymptotes are just two equations of a line, a plus and minus. You don't have to resolve that. You can leave it plus and minus. So you tell me if you have any questions. Okay? Yes.
The asymptote.
Mm-hmm.
How do you get radical 1 over radical 1?
So this is like your slope. This is almost like a point slope format. So you're going to take your y minus 1, whatever the y is. You're going to put a plus and minus. This is your slope. Because this comes from your x and your y guide. Where's your equation? Just take this. Oops, it's supposed to be y plus 2. What else I got? Just take these pieces up here and put them over here. This is your slope. So your slope is changing y over changing x. So underneath the y, take the square root of that. Underneath the x, take the square root of that. It's just changing y over changing x. And underneath the y and the x are both squared. So you can take the square root. Now, if you look at the book does the a and the b, but it has to switch the a and the b. And it does, but it has to switch to a and the b. So sometimes it's a and b, sometimes it's b over a. So, well, because here's the problem. It's whatever one comes first is your major axis. So the y could come first. So the y could either be a b or an a. So rather than try to figure that out, just remember slope, y over x. Because if you remember b over a, then you have to figure out, oh, when is it a over b? When did I switch my x? When did I switch my y? Because in this case here, over the x is the a, over the y is the b. So in this case, b over a. If I put my y first, and then my x, this is the a, then it's a over b. So it's just easier to remember slope, y over x. Yes.
So when you're doing like a complete the square one, is it just whatever variable they list first that you do?
Well, complete the square may come out a little differently because sometimes you end up with a negative on the other side.
Okay.
And when you have a negative on the right side and divide by a negative, it will switch those two around.
Okay.
It has to follow a subtract. The subtract has to be in the middle.
Okay.
I don't know if were you supposed to square a when you see squared it with a squared plus b squared? I use 6 in
These are already squared. Don't forget this is a squared, this is b squared. Try to remember like this. It's squared on the top, it's squared on the bottom. So when you find a, right, you take the square root of everything. So try to remember squared on the top, squared on the bottom. All right, so what do we have next? We have another, off the x-axis, whoever comes first, that's your major axis. So again, you need to draw your co-vertices just to graph the box, but we don't really have co-vertices per se because it doesn't sit on the hyperbola. Did you have a question, Ryan?
No, I was going to ask, do you need to check my
Oh, yeah, you said. All right, so we're good with this? You tell me. And again, when you go to your, it's going to be your b over your a, or just your y over your x. Try to remember it just as a slope.
Why is it that this is just like out of curiosity, but why are the foci like outside?
Because if you think about it, they're like a little parabola. So technically, this piece in here doesn't exist.
Oh, okay.
Your parabola would just really, your hyperbola really just looks like this.
Okay.
So there's really nothing in here.
Okay.
We need the center. We need to make this little box just so that we can draw your two little parabolas.
Okay.
So really that doesn't exist. All you're looking at are these pieces right here. That's what a hyperbola looks like.
Okay.
Do you remember back in I don't know if it's algebra 1 or algebra 2. You do these guys. They're like two little hyperbolas kind of slanted off of a slant. These were your x, y guys. So we don't really need to draw this part in here to get those. Yeah, we need to draw them, but then we don't use them. That's why we say the vertices exist. The co-vertices, we just need to plot them as well as the center, but we don't need to find them. We don't need, well, the center we do, but not the co-vertices. Okay, so we divide everybody by 6. There's no square to complete. Did we do this one in class? Yeah, we did this one in class. Okay.
Wait, I'm so confused.
Okay.
Why is it square root plus or minus square root of 2/3 for the square root of 2?
Over where? Here?
For the asymptote.
So if you take the square root of 2 over the square root of 3,
Oh.
yeah,
Or it's y over x.
it's y over x. If you wrote it like this, that's not wrong either. Technically, you shouldn't leave a fraction underneath a radical, but since you have 2 radicals, and we don't have to simplify those anymore, rationalize those. If you left it like that, that would be fine. I would probably write it like this, but if you wrote it like this, that's fine too.
So we
Don't
can
forget.
leave it with the radical in both?
Yeah, absolutely. There's nothing else to do to that. Right, here's to complete the square. And be careful of your negative signs here. When you take this piece by itself, that y has to be positive when you complete the square. You have to factor out that negative. When you complete the square, and then you get the 9, don't forget to, distribute it back out to get this one. What happens sometimes is when the right side, the constant side, is a negative and we divide by a negative, it ends up switching the terms around, and that's fine too. But when you build it, make sure you put the subtract in the middle. Like I would expect this slope that you would resolve that slope because you can find the square root of 9, square root of 1. And the good part about this is you can even graph this. You can graph the 2 asymptotes just to see if it passes through your center. So that kind of helps you to see if you got it right. If you graph these 2 lines in your y equals, put one in your y1, one in your y2, where they cross should be the center of what you found for your center. So it's a nice way to check. You can't really put your parabolas out there, but at least you can see if it's crossing at the center. And remember the foci, we add them because we want them outside of it. We want them inside those 2 little parabolas.
Don't switch it yet.
Okay.
I forgot the fact those are negative.
Yeah, that gets a lot of kids, and I'll tell you why. Because you see the subtract and you say, whoop, this part is the subtract, and then you forget that it belongs to the y.
Yeah.
Yeah.
But that one is
It does. It does.
Oh.
Yeah. But as long as you see where your problem is, don't go change everything. If you do the rest conceptually right, you're fine. Like the same thing on a test. If you make that mistake on a test, by now, I find that error, I just take off for that, and I follow yours through. So usually I put a little check because even though your answer is wrong, it matches your equation. My pre-calc regulars fall into that trap all the time. What they do is they just end up going like this. And that's wrong. Because they leave out the negative.
Is the y the major asymptote?
It's the one that comes first. Yes. It doesn't go on who's bigger, it goes on who's first. A subtract, think of it this way. When we did the add for the ellipse, an add is commutative property. It doesn't matter who comes first. So what matters there is the larger denominator. That's the major axis. In a hyperbola, it makes a difference when you subtract, right? 5 minus 3 is not the same as 3 minus 5. So we can't switch these. So whoever comes first in a hyperbola is the major axis. That's called the transverse axis, where your parabola goes off on each side. So technically, we just look at a hyperbola that technically looks like this, without all the little things in between. We just need to build all those things so that we can end up graphing that. Then we know how wide it is, we know where it's crossing. And so this, we complete the square. You factor out your negative, you completed the square, and we found it was equal to 0, so this does not make a hyperbola.
So that's all you're saying, no hyperbola?
Yeah, yeah. It's not a circle, not a hyperbola, nothing. I don't know what it would be. Again, don't forget to factor out that negative. This way, when the 9 is there, it's probably easier to remember to factor out. Good. All right. This is the last one. And the last one. The y one is the first one, is the primary one, so that is your major axis, is your y. And your asymptotes. Now, with this one, if you left this guy, radical 2 over radical 18, the radicals we do simplify. We don't rationalize, but we do simplify. This would be 9 times 2. This would be 3 radical 2. The radical 2's would come out, and you would be 1 over 3. That's how you have to leave this one. We don't rationalize denominators, but we simplify the radicals. That's why if you put it inside, it probably looks a little bit better. So make sure you keep your radicals in simplest form, fractions in simplest form. Right.
6 hours a day.
All right. So we're going to find the standard form of your hyperbola given some of the parameters. And again, you're going to do this just like you did your ellipse. You have to determine first who's your major axis, because it makes a difference where you put your, who you put first. So start with whatever they give you. If they give you vertices, this is a good place to start. So 0, 2, and 4, 2. So here's my translated axis. So which one's going to come first, the x or the y?
The X.
The x. So this is my translated axis. This is a vertex, this is a vertex. My hyperbola is opening up this way, right?
Yes.
So we're going to put the x first. Okay. Do we have a center? Can we find a center? 2, 2. Nice when they're that simple, right? So, can we fill in the h and the k?
Yes, we can.
Yes, we can.
I am funny.
Okay. What else can we find with just this?
A squared.
We can find a, so let's find a first. What's a?
A is going to
2. The distance from the center to the vertex, so 2. So this would be 4. So now, that's all we can get from there, right? So now we go to the other part that they gave us. They said the foci we're at -1, 2, and 5, 2. So C is, what's C? Can't be 2. It's 2 plus 1. It's got to be from the center,
Oh, right, 3.
3. Remember, C has to be the biggest. This is Pythagorean theorem you're doing in the formula.
E is 1
Your hyperbola, if you want to sketch it, maybe this makes more sense if I do this first. Right? So C is 3. So what piece am I missing?
You're missing B.
So how can I find B?
C minus A.
C squared equals B squared plus A squared plus B squared, right?
Yep.
So 3 squared equals B squared plus 2 squared. So this would be B squared is equal to 5. And do we need to worry about square rooting it? No, because all we need is the B squared. So we're just going to take that out and put a 5 in there. So your final equation equals what? Okay. Remember, C is the largest one here, because it's outside of everything else.
I always think you could look at
So it might have helped us if we drew the hyperbola first, so that you can kind of see those little parabolas. Because it's like a little parabola. Isn't the focus of your parabola inside of it? That's where the focus is. It can't be outside of it.
This is math class.
All right. Are we good with this? All right. Let's try another one. All right. Yeah.
Throw a curveball there was going.
Yeah. Made you think a little. So what should we start with?
I think we should start with the vertices.
Okay, so let's start with the vertices. We've got 3, 1 and 3, -5. So where's my hyperbola going? Off the what axis? The y. So it's going to go like this. Let's draw it. It's going to go like this. So can we find the center?
Yeah.
And what's the x?
3
3, good. 3, -2. So who comes first, the x or the y?
The y
So it's y and what?
minus, or plus 2.
Plus 2, because it would be minus a -2.
Minus x. Well, minus 3.
Okay. So we know the center, 3, -2. Can we find anything else given this? Find a squared? So let's find a. A is what? God bless you.
Bless you. 3.
A is 3. The distance from the center to the foci. Now here it's harder going over a negative, because you're -2. You're coming up 2, going 1 more. This is from 5 to 2. There's your 3. So this is your A. A is 3, so this would be 9. So we pretty much exhausted that little bit of information, right? So then they gave us an asymptote. The asymptote falls into your y plus 2 thing. There's your plus or minus. This is your slope. And somehow they got this all worked out. But what can we pull out of this that will help us?
Wait, why is it square?
Oh, it's not. Sorry.
Excuse me.
Sorry.
Don't you have to take the Q across?
Well, so, I'm sorry, say that again? 3 over the square root of x?
Because you have it.
Well, this is all going to resolve itself when I subtract 2 over here. But what does this line up with?
Isn't it y over x?
It's y over x. So you can do your y is 3 over x is equal to what? What does this, think one step ahead of you. Before you figure out that part, what does that line up with in either of these equations? The 2, right? Isn't this the slope? Yeah, watch. No matter how bad I make this line look, right? And we'll work this out in a second. But hold on to your thought there, Sarah, because we're coming at next. But when you're looking at this, this is almost like your point slope thing, isn't it? Remember your point slope format? Your y minus something, your y minus y1 equals x equals the slope x minus x1. It's almost like that, isn't it? So, of course you don't leave your line like that, right? You leave it in y equal because later you add this to the other side, which is what we'll do to that guy as well. But doesn't this still come out to be your slope all the time? If you factored this out, wouldn't this be x minus 4? Isn't this your slope? Okay, so but don't forget we're going to have to add this later, so it's going to come out a little bit differently. But this is your slope. So if your slope is 2, isn't that the change in y over the change in x? And now, isn't that what Sarah told us? Change in y, what's under y? Square root of y over, I don't know, my x. Really, think this one out.
Think it through. Makes sense.
Okay, watch. Let's do this for a second. Hold this off for a second. Let me take this equation. Guys, watch. Okay. This is what this would look like if I took your slope and I put your slope in here, if I put the 2 in here. This equation is the same as those two. Why? Because I can do this. Did I still put the square here?
It's okay.
It's one of those days. So I'll just do the positive one if it helps. I'm just going to do the positive one. So 2x minus 6. Then what do I have to do? I got to get y by itself. I got to subtract 2. So it's my equation. You just don't see the rest of it because it all gets distributed and pulled over. But how did I start? This is my most important part, is my slope.
You do e over b plus or minus over dx.
Don't do the plus or minus. Just, we'll keep the positive because it's going to work out anyway. Because you're going to put it back in there as a plus or minus anyway. So that part's not going to matter. But just keep the positive to keep things normal. So it would be 2x is equal to 3 divided by 2, and x would be 3 halves. Okay, so where do I put this? In the denominator of b, right? Weren't we finding b?
Yeah.
We just called it y and x right now because we dealt with the slope. But the slope says what is under the y? The y is a, and then the x is b. So we just found b. So this is 3 halves squared. So all I have to do is rewrite my equation to say y plus 2 squared over 9 minus x minus 3 squared over, this is going to be 9/4, right? So what should I do with the 9/4 since I can't leave it a fraction in the denominator? Put the 4 back up here. There's my equation. Your asymptotes that we do here to do this is just the equation of a line. It really matches your point slope, doesn't it? Your denominators.
But then they both have.
Isn't this the exact same, almost the exact same format as your point slope, right? So this guy right here, isn't this your slope? It's the equation of a line. What happens in algebra, a lot of teachers don't teach the point slope because